everyone. Hello, welcome back. I hope that the test went well for you, and now we're ready to start chapter 3. We're going to talk about quadratics. Hi, Miss Young. How y'all doing?
You know, just hanging out.
Doing the thing? Yeah. Okay.
Thought I would do some complex numbers with you.
That's right. We got to have a little bit of fun with this, and do our thing. So we're going to talk about complex numbers, and a lot of people just, dog on these babies, but we love them. They put a hair on our chest. So let's go.
Don't put hair on my chest, just so we're clear.
Oh my gosh. So complex numbers originated with this graph. Now, this is a graph that's not too crazy. We've seen the graph of x squared, the parent function x squared. We've done the transformations before. But mathematicians really like a sense of completeness. Like, I really like to know why things are the way they are, and I really like to know why things, work. Okay, that's just me, and maybe it's because I'm a weirdo or whatever. But as a mathematician, I like a sense of completeness. And one of the things we like to do as mathematicians is find the zeros, or we like to take a function like x squared plus 1, set it equals 0, and solve it. Well, I had a little problem here. And let's see what that little problem is, okay? So all of your life,
I feel like it's a big problem.
well, it could be, but, problems are...
It was such a big problem that there was a whole new, well, I guess I shouldn't tell you.
Yeah, you're going to see what happens. So, of course, if I were going to solve this, I could solve it by taking ones from both sides. And then I get x squared equals -1. Then what would you do to solve this, Miss Young?
Well, the way I would think about it at first is like, what number squares to get -1? And if I knew it, I might just put the answer down. And if I didn't know it, then I would take the square root of each side.
If I do the square root of x squared, that's how we get rid of the squared, right? So, but what thou doeth unto one side of the equation, thou must doeth unto the other. And I think we talked about...
Preaching math today, preaching it.
Preach it, sister. Okay, or brother, whatever. Okay, now the problem is when I try to take the square root of that right side, I don't know how, like Miss Young said a minute ago, she didn't know how to... what number when multiplied by itself is given -1, and you know what? Neither did any mathematician. Okay?
Because there wasn't one.
There wasn't one. But they ended up, to have a sense of completeness, it's like, caveman didn't need fractions. So caveman could just make little tick marks on the wall. And to a caveman, like 1/2 would be like mind-blowing. Okay? And, so we finally figured out maybe we needed parts of a number, so we got 1/2. And if we went on like down history, they maybe never had a need for negative numbers. The first person said, well, hey, what if we owed somebody some money? Once we had money, then we needed negative numbers. And then people's minds were blown. We're at the point now where people just don't like this number. And this number is the imaginary number, I. Okay, there is a number that when I square it gives me -1, and that happens to be I, and it would be plus or minus. Yes. So I is actually, we define it, and we'll define it more formally here, plus or minus the square root of -1. We have a new definition. Like, you can't, all right, so Miss Young, tell me about 4. What do you know about the number 4?
Well, if I have 4 objects, 1, 2, 3, 4.
Those are like pens and iPhones or calculators. That's not 4. Those are like things.
This is 4.
No. Those are things. I want 4. Tell me about 4-ness. What is 4-ness?
4-ness is when I have 4 things.
No, 4-ness is an idea. Okay, that happens to model the number of things you are holding in your hand. Okay, and it makes sense to us in the real world. But 4 is a concept, just like this thing is a concept. Frankly, all of this math stuff is a concept. Okay.
Ooh. Okay, sorry.
All right, we're enough philosophy. So let's just move on. All right. So we have the imaginary number I, and I is defined as the square root of -1, and that means that if we square it, we get something that gives us -1, and therefore we can solve that equation, and it allows us to solve a whole bunch of equations. Anything where we might get a negative number, when we get x squared, or when we get a square equal negative number, now we can solve it, and it involves these i's. And it's not really all that unnatural. It's just very badly named. People gave it a bad name, and people hate it.
Because it was like somebody was like, okay, we've got all these numbers and we call them real numbers. So what should we call the numbers that are not the real numbers? Yeah. I know.
Call them imaginary.
Because they're not real.
We could call them fake.
Guys, Yeah, right. But they are real. And if you need an application to, just like everyday life, if you are thinking that maybe electrical engineering is in your future, the concept of circuits run on a complex number system.
That's exactly very much true. And so, all right. So anyway, it's just naming matters. It's just like very few people name their kids Adolf anymore. Okay.
Why?
Because of Hitler. Okay. I wouldn't I wouldn't name my kid Adolf. I mean, gosh, I would.
No.
I probably would not name my.
No, that name is ruined.
Yes, that name is ruined. Okay. I mean, I'm sure there before the 1940s, there were probably very nice humans who were named Adolf.
I agree.
And now there aren't any hardly named Adolf. Okay. All right. So anyway, what we do, we were able to solve square roots. Like Miss Young probably likes this question. You know a number that gives you 25 when you square it, right, Miss Young?
I do.
What number is
5
that?
times 5 is 25.
Oh, and maybe I should go back to get my pen. But yeah, Miss Young in her mind knows 5 times 5, and I thought I had it, but I guess I didn't. Silly Mr. Bobby.
Giving away the secrets.
No, grab your pen, silliness. She knows 5 squared equals 25, or 5 times 5. Okay.
On that last slide, we didn't talk about I squared, and it's going to be really important here.
Okay, so we want to go back to that one and might as well.
Yeah, I think we need to. We got sidetracked.
We got Adolf tracked.
So here's what happens, guys. If we want to turn an imaginary number into a real number, we just need to undo the square root that made it an imaginary number. So I could take this left equation and I could square each side of the equal sign like this, okay? And I would get I squared is equal to -1. So this is kind of how you would turn a complex number into a real number, is to square it, but it also defines I squared for us. Mm-hmm. So these are the two concepts that you really need to keep in your mind. I is the square root of -1. It's imaginary. I squared is -1. It's real.
Yep. And we'll talk maybe a little more about this later on as we go. So, all right, let's go back to where I was a minute ago, where I was trying to simplify some radicals that had negatives in it. So I started with the second problem, and we know that 5 squared is 25, but so I really can kind of imagine this as the square root of -1 times 5. So what I would maybe in my head think the square root of, and I'm going to write this as 25 times -1. And you'll see why in a second. And when I have a negative, when I'm writing negative, sometimes I'll put the negative number in parentheses. Miss Young probably does the same thing. You may not, but I just finished 5 days of grading AP exams, and I saw students who had -4 times -1 and got -5. They wrote it down, and that's not true. -4 times -5. They wrote them next to each other, and then the next line, they did subtraction. Okay, so I want to force myself to do it. So I know the square root of 25 is 5. I'm going to put the thing that I can take the square root of first, and then the square root of -1 is I. So I usually put the thing that I know to take the square root of first, and then the thing I'm not so keen on second. What's so exciting to your left? Huh?
My daughter just walked in, and I was going to tell her that I made a zucchini hummus lettuce sandwich for myself and that it was really good for lunch. And so I was going to mute you guys so that I could tell her that. But now you guys know what I ate for lunch too.
Okay, that was nice. I had an apple and slightly cold pizza. So thanks for that.
Oh, and there was some avocado on it. There's half an avocado right there. Okay. So one of the tricks that I like to use, guys, instead of having to write out this step right here every single time, if there's a negative underneath the radical, I make it positive and pull an I out, which sounds horrible.
Yes, but I have the square root of 5 still.
Right.
Basically, every time you got a negative under the square root, you're going to have an imaginary number, okay? So I don't care how you do it as long as you get, now what if you did this? I wrote the square root first. What if you did this? Which one's right?
So this is where math gets stupid, right? If the number doesn't have a radical over it, like 5, then we would normally write the number and then the I. But if the number has a square root on it, like the square root of 5, then I comes first.
And the best reason I can give you is, guys, I don't have the best handwriting, and some of your handwriting is worse than mine, okay? So if you're going in a hurry and you write this, you write your I like halfway under the radical and halfway under. So that's supposed to be like 24. And I don't know if that I is supposed to be under there or not. Okay. So usually if there's a square root, one thing that if there's still a square root in the answer, they usually put the square root on the back end so there's no ambiguity. So that's kind of ambiguous. If I write this, I square root of 24, now there's no ambiguity whether that I is under the square root or not. That's the best reason I can give you. I'm not going to mark it wrong if it's clear, or if you put like if you put the parentheses here or something. But generally, if there's still a square root in your answer, we drop it on the end. Okay? All right. So using what Miss Young did below, we know we're going to have an I because we have a negative under the square root. But what about a negative out front?
That's okay.
That's okay. That's just going to be a negative number. That's like a -1. So I'm going to have a negative. I'm going to have an I.
As soon as he writes I, that turns this 49 into a positive.
At least mentally. And then I can look at this 49. Can I take the square root of 49? Yes, I can. And that is 7. And if you wrote I times 7, that's fine. But if you want to check it in the back of the book, I'm guessing it's probably going to be 7 times I because of the stupidity that Miss Young was talking about earlier.
Yeah, and that, well, and really this makes more sense because it's telling you how many imaginary units you have. Like you have 5 imaginary units with 5i.
Now the last one down there in the bottom right, 48 is not perfect. Hi, Leo. That's not a perfect square. It's close to a perfect square, but it ain't. So I have to simplify radicals. Now, there's lots of different ways of doing this, but I'm looking for the biggest perfect square that divides 48. And I just kind of work my way down the line. 1 does, but that's not the biggest. 4 does divide it, 4 and 12, but I wonder if there's any more. 9, not going to go into it. What about 16? Does 16 go into 48? Let me double check. That's 16 and 3, ain't it? Yep. And then what about 25? Nope. And once I get to halfway, if I'm past halfway and it doesn't work, I'm done. So 16 is the biggest one. Now you can do it however you want, but I know 16, I know I'm going to have an I in it because of the negative. And mentally I can do the plus thing. But then I'm going to just make this 16 times 3. Now I don't know how Miss Young likes to have radicals, but by this time you're in your high school career as a senior, you should be able to figure this out yourself or have done it before. 16, square root of 16 is 4. I still have the I, square root of 3.
Yeah. Just to make things more complicated, it goes number, and then I, and then square root number.
Now, if you'd have done I4 square root of 3, I'm not going to have a conniption. Miss Young might, but,
I'll throw a huge fit. The biggest fit you've ever seen.
Yeah, okay.
They'll be like foaming in the mouth and all the kinds of things.
Yeah, well, that's okay. I'm the one that assigns grades for this class, so that doesn't matter. Okay. All right. So, let's get rid of the writing here. So basically, like ogre, is it the number system's like an ogre?
Like an ogre?
Yeah, like an ogre.
Like the green guy?
Yeah, like Shrek. It's like Shrek because Shrek has layers to him.
No.
Shrek is like an onion because he's sticky, right?
No.
How many of you have seen Shrek? Am I the only one who likes Shrek?
Of course not. But I just was not expecting you to say that.
Numbers have layers, like an onion has layers, and the complex number system has layers as well.
Yeah. Agreed.
Complex number system is like an ogre.
What's the innermost layer of the complex number system?
The natural numbers, the numbers that your whole life, most human beings learn to count 1, 2, 3, 4, thumb. Okay. I actually had my college professor told me that story. His child learned to count 1, 2, 3, 4, thumb. And he was very upset because he was a math professor and his daughter thought the next number after 4 was thumb. And
to me, because it's not a finger.
Yeah, he kind of messed her up, and it took her a long time to learn math. Anyway, the natural number system is what I just said. Most humans count 1, 2, 3, 4, 5, and that's why we're cool with that. The whole numbers, you just add 0. 0 really like freaks people out, and that's actually what made the Mayans such a rich culture. Is they're the first ones who really contemplated and worked with 0.
Just the fact that they were like 0, that's what made them a rich culture. Yep.
It actually allowed them to do the calendar that they're so famous for, and allowed them to have a number system that worked.
My father-in-law did his graduate work on anthropology and math, like where they meet each other.
Yeah.
And he wrote his whole thesis on the fact that he suspected that the number 0 was shaped like it is, because the Mayans, the way they did math was dots and lines using fingers in the dirt.
Yeah.
And if you do like this, like stamp with your hand, it looks like the number 0.
Yeah. It actually does look. I went on a cruise once to Mexico and went to visit Mayan ruins, and the tour guide took us through and showed us like some of the symbols on the structures and drew it in the dirt, and exactly like they did. So it really did allow them to do architecture and
it was very cool.
Yeah, and making a calendar, a reliable calendar, actually is kind of important, like in early man, because like you kind of know when to plant so that you can grow the food, so that you can have stuff to eat, so that you don't die. Okay, that was kind of.
If you eat green things, gross.
Okay. Then they got fractions and then real numbers, square roots. Then math got weird and people got these irrational. Like these ones aren't like crazy. Okay, square root of 3 or pi, or those aren't crazy. They're just ones that are not fractions. Rational means fractions. So this number system keeps getting bigger and bigger, and we ended up with this new category called imaginary numbers that we're talking about. And all of that together is complex numbers. Now, one day down the line, when people finally embrace complex numbers and are okay with them and they don't freak out because of the word imaginary, I bet you there'll be some other number that we haven't even contemplated yet. So,
I bet so. I bet we have not discovered our last number set.
Correct. Okay, so when we have these imaginary numbers, they add and subtract. And remember, I is the square root of -1. So like, let me kind of like back up. What if I had back up, literally. So this is not the purpose of this lesson, but what if I had 2 square root of 3 plus, let's say 4 square root of 3. You should remember this from like middle school or an earlier algebra class. How did
Not middle school.
Maybe not middle school, but whatever.
So you've got 2 square roots of 3, and you got 4 square roots of 3, and you're going to combine them together to make 6 square roots of 3.
Okay. So when we did this in an algebra class before, that would be 6 square roots of 3. We add radicals like we did like terms. We add like radicals. So I is a square root or radical. So we just add i's like radicals. So I can add the imaginary parts and the real parts. So I have 7 and -2. Last time I checked, that was -5. Or
how about +5?
Yeah.
You should check from the time before that.
Yeah, because maybe it's changed since the last time I checked. And then this -2i and 4i, using the argument Ms. Young gave us a minute ago, would be +2i.
Yeah. You got 4 eyes, because you're a nerd. You got 4 eyes.
Well, I wear glasses. No, you don't really wear glasses. Miss Young really doesn't wear glasses when she's in the video.
I mean, I'm wearing, well.
She doesn't wear glasses. Neither of us are wearing glasses right now. She wears those other regular glasses because they're the blue screen glasses. She's actually.
Yeah, they protect my eyeballs. Yep. I have 20/20 vision. But anyways, you have 4i, and you take away 2i, You got 4i, and you take away 2i, and that leaves you a 2i.
So we have -9 minus I in this one. But when we have a minus in front of a set of parentheses, we have to distribute that negative, right? So negative -2 becomes +2. Do not try to do this without distributing it. I mean, you can, you might be able to get away with it, but you're going to lose a point. Eventually, you're going to lose a point, and then you're going to be sad, and then
just rewrite it. Don't be lazy.
You want to, and then you're going to get a job where you're having to pick up heavy objects for a living, and you're not going to make as much money.
Did you say carry heavy objects?
Yeah, for a
I don't
living.
want that job.
No, I don't want to pick up things. I want to. This is as heavy as I want to pick up. Because I have a master's degree in math, I never have to pick up anything heavier than this.
He's lying to you. He has dogs.
Yeah, I chose to pick them up. They don't pay me. This is as heavy as I ever have to live because I have a degree.
Also a lie. You have to pick up textbooks.
Oh my gosh, you're so exhausting. Okay.
Let's move on.
Let's move on. All right. So, what about multiplication of these puppies? Well, we did this earlier. We're going to have to do some stuff. I got an I here. I got an I and a square root of 45. So Miss Young likes to take that I, poke the eyes out. Go back, silliness.
He's going the wrong direction. He doesn't know which arrows to hit. It's okay.
I don't have to lift heavy objects, but I don't know my left from my right. So this would be I square root of 45. And let me see here, times I square root of 6. Okay.
I just noticed you're using green to write. It's weird.
Oh, I switched from purple because I wanted to do different like terms. I'll go back to pink.
It's okay. You do you.
I'm all about the pink. You know this about me. It's not even Wednesday. What day is it? It's Thursday. So I'm going to have I squared here. Well, what's the square root of 45? And the square root of 6. Square root of 6.
45 is like 6 point. Oh, you want me to reduce the radical? 45 is 9. This puppy is being loud. Sorry. 9 times 5.
And square root of 6. I can't do nothing with that guy, can I?
No, but maybe you should. Oh wait, we already put them together. I didn't see you do that.
What, the I squared?
Yep.
What was I squared a minute ago? Miss Young told us a little while ago. I squared is -1.
Yep.
And then the 9, square root of 9 is 3. And that leaves me the square root of 5 times the square root of 6. Now, I can't simplify either one of those, but I can mash them together under one radical and make it the square root of 6 times 5. So I end up with -3 square root of, do I need to write 5 times 6, or can I know that that's 30?
Maybe we can just write it as 30. Although at this point, guys, you probably do want to check to make sure that what's underneath the radical doesn't simplify any further. So in my head, I said, okay, well, that's 5 times 2 times 3 in there. So I'm not creating any perfect squares. But you could go through your multipliers to get 30, 1 and 30 and 2 and 15, and try to get one that has a perfect square in it. You won't.
And we're not going to teach you how to simplify radicals in this class. I mean, like, you should be able to simplify square root of 45 and the square root of 30, or not simplify square root of 30. Now, if we asked you to do it in decimal, that'd be cool too. But right now, if it says simple radical form, we want to leave it in radicals, and that may be the case, okay? So I can do the square root of 100, which is 10.
Can we go straight to the answer?
So this would be 10i.
10i.
Okay. And then I'm going to have another I. Can I do anything with square root of 2? Not really. So now I got I times I. That makes a -1, right?
It does.
100 square root of 2.
Can I know why it went to 100 though?
Because I messed up. Can I erase just the 1 0 in there, maybe?
Yeah. So he did I times I right here, which is I squared, which is how you make that imaginary number real, -1. So -1 times 10 is -10.
All right. Sorry about that. My first mistake. Okay. So that was just simplifying radicals or multiplying radicals with negatives under the square root. Now when we have a complex number that's got imaginary parts and real parts like this, we're going to basically do the distribution thing that we did with the binomials before and see what happens. So when I do 3 times, I was doing good with my pen the other day.
You were.
Stats. We've been making a bunch of videos lately, and I think we've been making too many stats videos lately that don't have as much annotation. Oh gosh, quick. So that's going to be 6 and then 15i.
I like it.
You will allow it. And then
negative 8i.
Negative 8i.
And negative 20i squared.
Okay, now I know that's I squared. Can I just put -1 there, or do you want me to do this? I guess I'll do this right initially.
That's to say you just did it, so I don't.
Did it. Yeah, it's too late now. If you could do that, and I know I squared is going to be -1, so that last term is going to straight up be really plus 20. If you could do that much in your head, maybe watch yourself, but okay. So I'm going to end up with 26. What is that, 7i?
7i, yeah.
Okay. All right. So help me. Do not say that's 49 minus 36i or plus 36i squared or whatever. Remember, we got to drop it down twice and multiply it out. So 7 minus 6i times 7 minus 6i. So we would then get 49 minus 42i, and we're going to get 2 instances of 42i's. And then 36, we'll get plus 36, and I'm going to just put -1 there to kind of make it. Is that okay?
Yes. What happened there is he did 6i times 6i, 36i squared, and I squared became -1.
Now, I know that, so what's that mean on the end is going to be -36. Oh, that's going to give me -82. I'm going to do the 82i because she underlined it. But I'm going to get 13. Why? You want to explain where the 13 came from? Or
49 minus 36.
Because it's minus, okay? All right, last problem. This one's kind of important for our purposes in life. We're going to get 16 minus 20i plus 20i minus 25i squared. I've used both of these. I don't know which one I like better. But I know on the end that minus 25 is actually going to become a positive 25 because of the I squared.
Yeah.
So 16 and 25 make a big old fat 41. What about the 20 I's?
They went away.
They went away. These guys are called conjugates.
They're actually called complex conjugates.
Yeah, that too.
And complex conjugates make real numbers.
You know what? I think I have this on the next slide.
You do?
I do.
You are magical.
Almost like I planned to teach this. Oh, maybe not. I had it later. No, I guess I didn't. Well, I had it on the title, like right here. Duh. It's in the title slide.
At the top.
Yeah, I should have said complex conjugates, but whatever. Float your boat. All right, moving on. So the powers of I, we've already talked about this. We had I squared.
I can't stop yawning. Not that you're boring. You're not boring.
Yes, I am. I'll take that personally. That equals -1. We already established that, right?
Yep.
What about I cubed?
I cubed would be I times I squared.
That would be correct. It would be I times I squared. But we already know I squared is -1. So
it would
this
be I times -1 or
negative I.
Negative I.
Okay? And I to the fourth.
I squared times I squared.
I squared times I squared. What's I squared?
-1.
but I got 2 of them. So I get -1. What's -1 times -1?
That's +1. That's me.
Yeah.
Positive and number 1.
This is, oh my God, you're ridiculous. All right, +1. All right, guess what happens? It starts all over again. If I do I to the 5th, that would be I to the 4th. Every time I make a block of 4, guess what? That guy goes away.
Yep.
So this is really just 1. So I just get back to the beginning. And it starts all over again.
Yeah.
Okay? I'm having more.
So the pattern goes I, in case you can't read this.
Yeah, I probably should. I should.
-1, -I, 1. I,
negative, negative,
yeah.
and then +1. It's those dots on the stupid eyes that are messing me up. If I don't make a distinct dot, it tries to connect them, and that's a Zoom thing. That's not me. It's not me. And so
you're thinking about here exponents. This is, I don't know why it's continuing to write.
Okay.
This is to the 1st power, to the 2nd power, to the 3rd power, to the 4th power, to the 5th power, to the 6th power, to the 7th power, to the 8th power, to the 9th power, to the, you think I'm getting my point across here?
Yeah, every 4th one. So if your exponent is divisible by 4, it's going to be +1. It's going to cycle through the beginning back, or go through the whole process of 4. If you've got a remainder, if you try to divide the exponent by 4 and have a remainder of 1, it's going to be I. If you divide the exponent and have a remainder of 2, it's going to be -1. If you divide the exponent by 4 and have a remainder of 3, it's going to be -I.
And if the remainder is 0, that means it's divisible by 4.
That's what I said. So.
I know. I was taking them back full circle, Mr. Bobby.
Right. And it's actually sometimes does appear on the ACT or, whatever. GRE, I think. Even. All right. So we can move on to division, I think. Yep. Now, complex number division needs those complex conjugates. It doesn't actually depend, there is no division like there is necessarily. So what we end up doing is we want to get rid of the imaginary part in the denominator. That's our goal. So you've been told probably, get rid of the square root in the denominator. Well, now I have a square root in the denominator, and the idea is to multiply by the conjugate. So if I take this guy and I multiply him by 3 plus 2i, this is what we talked about a little while ago with the complex conjugate. If I multiply a complex number by its complex conjugate, the square root or the imaginary part goes away. So, but I can't willy-nilly go around multiplying things by what I want. I can only multiply by 1. Because essentially this is a fraction. So if I do it on the bottom, I got to do it on the top as well.
When you write your conjugate, make sure you note that it's only the imaginary number that changes signs. It's only the imaginary number that changes signs.
So on the top, I'm going to get 9 plus 6i when I multiply that through. And then on the bottom, I'm going to do the conjugate thing, but I'm going to get 3. I'm going to get the 6i and the minus 6i. When I do the 3 times 2i and then negative 2i times 3, you can write that, but in the interest of time and the fact that my handwriting is being persnickety today, I'm not. I'm just going to get 9. What?
Can we do 3 times 3 and get 9?
We could. Let me maybe go back and fix that. Oh yeah, I was wondering why you're giving me the stink eye. Yeah, that would help, having the right answer there. So that would be 9.
So he's skipping the 2 middle terms, guys, because when you multiply conjugates, those middle terms will always subtract to 0.
And if you want to write them, and that's fine. I just was.
If you don't trust us,
do it. They probably don't because we are kind of shady.
I think it looks pretty bright in here.
Our future is pretty bright. Did I tell you? You know what? Do you know why you shouldn't trust trees? Because they're shady.
Mm-hmm.
Leo didn't like the joke.
He didn't. He was not a fan.
That's the end of the joke. You might actually see this written also as 9/13 plus 6/13 I.
Yeah.
Okay. I would take either one, but if you were looking in a book or checking your answers in the back of the book, you might see it that second way. That's cool.
That's called standard form and complex numbers. And what will happen is when you separate them, sometimes one of the fractions will simplify. So if you go and you check your answer and it doesn't match, one of the first things you need to check is, did you separate? And then after you separate, make sure the fractions don't simplify.
All right, why don't you try that one? 3, 2, 1, we're back.
You did a good job.
Good job. You know how I know? Because in my friendly neighborhood calculator.
Why are we looking at your motorcycle?
That's my, are you not seeing my smart view?
I am now.
Okay. So let me kind of like ruin my entire life as a math teacher. When I go and I press,
I think you're going to show them.
I am going to show them. Wasn't going to, but I'm going to show them anyway. So like I could do this 2 minus 3. I'm just making up numbers here. Where is the I? It's under the I button.
Is it turned on? Do you have to turn it on the Inspire? You have to turn it on the 84.
No, yeah, you don't have to do that here. So if I have it, and I can do, I'm just making up a problem here. Oops, let me put a parenthesis in there. So I probably am going to take your calculators away at some point for this one.
Now that he's showing you this trick. Or he's just going to make you show your work.
Will make you verify that this is not why it is. So, okay, there's ways I can neutralize your calculator, but it does do it for you. I mean, that one, come on, let's be honest. It took me longer to type that than it did to actually do it.
Yeah.
I don't remember the problem, but if I do the fraction template and do 2, I think it was 2 plus 3i or something. Or, get that out of there. And I'm just going to make up
the square root of -1 in place of the I. Will it still do it?
Probably. This is like a really good calculator. Let's see. Oh, it even did the division and dealt with the negative square root of I. But yes, okay. So your Nspires will do this. But I'm probably going to make you like show some work here. I'm not going to just let you type in a bunch of things. I may do 1 or 2 just for kicks and some easy points, but there's going to be a problem where you're going to have to verify something, okay, or explain something. I could totally see me doing one where a kid worked.
You could put it on there where something's wrong and you got to figure out where it's wrong.
Yeah, you still need to know how to do this for the, right. So don't think I'm getting out of it. You're getting out of anything. All right, and that completes the lesson for 3.1. I hope you have a wonderful afternoon and that your future is so bright that you gotta wear shades. Bye.
That was too long. That was awkward. It was an awkward pause for me.